So we've built this incredible machine. It's read the internet, it's absorbed trillions of tokens, it has billions of finely tuned dials. It can take any piece of text and predict what word comes next with remarkable accuracy. And here's the problem. That's all it does. The model that comes out of pre-training, what's called the base model, is not a chatbot. It is not an assistant. It does not want to help you. It's an internet document simulator. What do I mean by that? If you give the base model a prompt like what is the capital of France, you might expect it to say the capital of France is Paris. But it won't, because that's how an assistant would respond. The base model isn't an assistant, it's a text continuation engine. It's been trained to predict what would come next on the internet. And on the internet, a question is usually followed by more questions, or a forum thread, or a list of related searches. So the base model might continue with something like a string of more capital city questions, one after another. Or it might generate something that looks like a Reddit thread, or a Wikipedia article starting from the middle, or honestly, something completely bizarre and inappropriate, because the internet has plenty of that too. The base model is like a very well-read parrot. It can mimic any style of text it's seen, but it has no sense of what's helpful, what's appropriate, or what you actually want. It just continues text the way the internet would. So how do you turn this raw, undirected prediction engine into the polished, helpful assistant you talk to every day? Two more steps, and both of them are about teaching the model how to behave. The first step is called supervised fine-tuning, SFT for short. Here's how it works. The AI company hires a team of human labelers, experts in their respective fields, often hundreds of people, and asks them to write example conversations, thousands and thousands of them. Take an example. The user asks, "Explain quantum entanglement to a 10-year-old." And the ideal assistant response might be something like this. The human labeler writes both sides, the question and what a perfect, helpful, safe, clear assistant response would look like. They do this for every kind of conversation you can imagine: coding questions, emotional support, factual queries, creative writing, math problems, refusals to harmful requests, all of it. Then you take all these example conversations and train the model on them. Same process as before: show it the conversation, hide the assistant's response, ask it to predict, check, adjust, the same gradient descent, the same backpropagation, the same dial turning. But now the model isn't learning from random internet text, it's learning from curated examples of how a great assistant should talk. And very quickly it picks up the pattern, it learns the format, it learns to be helpful, it learns to be clear and structured, it learns when to refuse. After SFT, you have something that actually feels like a chatbot. You ask it a question, it gives you a direct helpful answer. That's a massive shift from the base model. But there's still a ceiling. The model can only be as good as the examples it was shown. It's imitating. And for really hard problems, complex reasoning, tricky math, multi-step logic, imitation only gets you so far. That's where the second step comes in. Reinforcement learning is where things get really interesting, and I think it's the step that most people don't know about, but it's arguably the most important development in AI in the last 2 years. Here's the idea. Instead of showing the model examples and saying imitate this, you give it a problem and say figure it out. You give the model a hard math problem. It tries to solve it. It generates an answer, maybe a long chain of reasoning step by step. Then you check, did it get the right answer? If yes, reward. This was a good approach. Reinforce it. If no, no reward. Try again, try a different approach. And you repeat this over and over, thousands of problems. And each time, the model tries many different approaches in parallel, and the ones that lead to correct answers get reinforced, while the ones that don't get weakened. Here's what's remarkable. Through this process, the model doesn't just learn the right answers, it discovers strategies. It figures out on its own that breaking a problem into smaller steps helps. It learns to double check its work. It learns to try a different approach when the first one isn't working. That thinking phase you see in modern models, where it reasons through a problem step by step before giving you the final answer. That wasn't programmed in by engineers. The model discovered that strategy through reinforcement learning. It figured out that thinking step by step leads to more rewards. Let me tie all three stages together with an analogy, because I think this makes the whole journey really clear. Think about how you'd learn a subject, say physics. Pre-training is like reading every physics textbook, lecture note, and article ever written. You're absorbing a massive amount of raw information. You know a lot of stuff, but you can't necessarily do anything with it yet. You haven't practiced. Supervised fine-tuning is like studying worked examples. Someone shows you a problem and walks you through the solution step by step. Here's how an expert would approach this. You learn the format, the method, the style. Now you can imitate a good answer. Reinforcement learning is like doing practice problems on your own. Nobody shows you the solution. You have to figure it out. You try things. Some work, some don't. Over time, you develop your own problem-solving strategies. You get genuinely better at thinking, not just better at imitating. That's the progression. Reading, then studying worked examples, then practicing on your own. And each stage builds on the last. I want to close this section by answering a question that I think is really worth sitting with. When you open ChatGPT or Claude and type a message, what is the thing on the other side? Here's the most honest answer I can give you. You are talking to a statistical imitation of expert human labelers, built on top of a compressed representation of the internet. Let me unpack that. The foundation is the compressed internet, trillions of tokens of human text absorbed and distilled into billions of parameters. That gives it breadth. It knows about cooking and law and Python and history and medicine, because all of those were in the training data. On top of that foundation, it's been taught to behave like the best version of a helpful assistant by imitating thousands of examples written by human labelers and then refining itself through reinforcement learning. It's not a person, it's not conscious, it doesn't have experiences or opinions. But it has absorbed so much of human language and been so carefully shaped to be helpful that the result is something that feels remarkably like talking to a very knowledgeable, very patient person. And now that you understand what it actually is, the data, the training game, the neural network, the transformer, the post-training, you're in a position to use it much more wisely than most people do. Which brings us to the final piece.